Hello, welcome to T Classify. I'll be answering WAEC 2018 Chemistry Theory, question 4B, Roman figure 2. The volume of a sample of methane collected over water at a temperature of 12 degrees C and a pressure of 700 mm mercury was 30 cm cube. Calculate the volume of the dry gas at standard temperature and pressure. Given saturated vapor pressure of water at 12 degrees C is 10 mm mercury. Now let's solve this. So we have the volume of a sample of methane collected over water vapor. So we should know here that this gas is collected over water vapor, then it is likely to saturated with water vapor. Then from the question given above, our pressure 1 P1 is equals to 700 millimeter mercury, because we are given that the volume of a sample of methane collected over water vapor at a temperature of 12 degrees C and a pressure of 700 mm mercury was 30 cm cube. Then actually here we have to calculate the volume. That volume is volume 2, that is P2. Then it means 700 mm mercury is our P1. Then from this first statement again, we have the volume of a sample of methane collected over water vapor at 12 degrees C. So that 12 degrees C, that is T, is going to be T1. Then we have 12 degree C. Then we have to convert this degree Celsius to Kelvin. Then we have 12 degrees C plus 273 plus 273 Kelvin. That is standard Kelvin. Then we have it equals to 285 Kelvin. So that is our T1, 285 Kelvin. Then we have from the first statement again, we have the volume to be, then they said the volume, that is our P1 is equals to, so our P1 is equals to 30 centimeter cube. Then they calculate the volume, that is P2. We have to calculate volume 2, calculate the volume of the dry gas at STP. So having the STP, it means that is we are going to use standard temperature and pressure. Then our T2 is going to be standard temperature. So T2 is equals to 273 Kelvin, while our P2 is going to be a standard pressure, which is 760 millimeter mercury. 760 millimeter mercury. Then don't forget that our pressure 1, they said it is collected over water vapor. Then it means it's not actually 700 millimeter mercury. Then we are going to subtract our P total. That is what we have from the, that is law of partial pressure. That is P total is equals to P gas plus P water vapor plus P water vapor. Then from here we know that to calculate the real gas pressure, that is P gas, we are going to have P gas is equals to P total minus P water vapor. Then our P total here is 700, we are given, that is 700 minus, then the pressure of that saturated pressure is 10 millimeter mercury given in the question, that is 10. Then when we subtract this one, we are going to have 690 millimeter mercury. 690 millimeter mercury. That is our P1. So this is the real P1 we are having from this question. Now solution to the question to calculate V2. So we use our formula P1 V1 over T1 is equals to P2 V2 over T2. Then making V2 the subject of the formula, we are going to have, that is by applying cross multiply. Then we are trying to make V2 the subject of the formula. We are going to have P1 V1 T2 all over P2 T1. Then by substituting the formulas, we have V2 is equals to 690 millimeter mercury, that's our P1, multiplied by 30 centimeter cube, multiplied by 273 Kelvin, that is our temperature 273 Kelvin, all over. Then our P2 is 760 millimeter mercury, then multiplied by our T1, which is 285 Kelvin. Now we use millimeter mercury to cancel millimeter mercury, then Kelvin we cancel Kelvin. Then our P2 is equals to, when we multiply 690 by 30 by 273, we are going to have 511. We have 5C. So when we multiply the numerator part of the equation, we will have 5/6. So we are going to have 5/6. So that is what we are going to have here. So we are going to have, that is when we multiply the numerator, we will have 5/6 511 00 centimeter cube. That is the remaining units for the numerator part, all over 216600. Then our answer, when we divide the two together, we are going to have 26.09 centimeter cube. So that is what we are asked to calculate. That is the volume 2 we are asked to calculate. So the V2 here is 26.09. If you like this video, click like and subscribe for more videos. You can still visit our YouTube channel www.educateafricans.com. Thank you. God bless you.